So, last lesson, we established that vertically opposite angles are equal. So we drew this together with the idea of angles on a straight line summing up to 180 degrees, and from that we're able to deduce that, well, okay, if I have angles that are vertically opposite, like these orange dots and these purple crosses, then they're going to be equal. And we can actually see this visually, like even just by looking at it. Well, like this angle looks very similar to this angle, and this one here looks the same as this one here. So visually we can see these things, but we just needed a more rigorous sort of mathematical proof using our logic that, well, these summing up to 180 on a straight line, we can just shift our perspective and see that all of these angles are a collection of angles on a straight line. So a lot of these supplements will be equal to the vertically opposite angle. Now, I talked last video about the idea of taking something small in angle geometry and expanding it out, looking at the bigger picture. Now, I showed you this picture here. This is where we ended last lesson. Now, I'm going to zoom out a little more. And we see that this was part of an even bigger picture. And this is a particular topic which talks about, well, when two parallel lines are drawn, like these two, and I'm going to indicate that they're parallel by drawing these little arrows here. These tell us that these are parallel lines. And if they're cut, both of them are cut equally through by what we call a transversal. So just another straight line that cuts all the way, slices through both of them. We get even more angle relationships on top of the ones we have already discussed. Now, for the next step, we're going to look at this particular angle here. And when you measure, and I'd encourage you at home to draw two parallel lines, draw a straight line transversal through them, make them as accurate as you can, use a ruler and everything. And when you actually measure, for example, this angle, and say some other angle here, you will get that both of these, this one and this one, add up to 180 degrees. And you can do this as an investigative task at home. I know it feels like a bit of a cop-out. I'm just stating something, and usually we like to, learn things kind of through intuition and proofs. But this is a good example for you to learn by doing. Actually measure these, and you should find that given you have parallel lines, and this is as accurate as you can, this angle here, as well as this one, will add up to 180 degrees. So this is the first, let me zoom out here actually. Now this is the first extra angle relationship we observe. And I'm going to draw just a segment of our big picture here. I'm going to draw this little segment here with my two parallel lines and part of my transversal. So we have here, here, and here. These two angles here, so this one and this one, are what we call co-interior angles. And I'm going to write that down here. These are called co-interior angles. And we call these co-interior because we can think of them as sort of inside. They're enclosed in something. A lot of the angle relationships you'll observe don't necessarily. But they're closed within some space. They're confined to two parallel lines and a transversal. So we call them co-interior. They are interior inside some angles. So some lines here. And we know that, we know that these add up to 180 degrees. And we can prove that by measuring this, and I would encourage you to do that at home. Now, all right, we have, so pausing for a minute, we have that this angle here that I've identified, that one, as well as this one, sum up to 180 degrees. Now, how is that similar to what we've done previously? Have a think. This angle and this angle summed up to 180 degrees. This angle and this angle sum up to 180 degrees. So by that logic, shouldn't this angle be equal to this angle? Because this is a supplement to this, because they add up to 180, and this is a supplement to this, or this is a supplement to this, because they all add up to 180. So what I'm going to do, I've just done this in black because I didn't want to give it away too early, but this now, we can color code it. Oh, that's a slightly different color. Sorry, I'm very picky when it comes to this stuff, you can probably tell, but we have another X, another purple X marked on our original shape. Now, from here, there's a couple of ways we can go, and there's a bunch of different possibilities and ways to find different types of angles when you have the spatial freedom of two parallel lines cut by a transversal, and once you know all the angle relationships. But we can find all of these other angles, these unknown ones, so 1, 2, 3, from some of the angle relationships in our previous videos. Now, you can have a go, but I'm going to do a couple here. Well, I know that this X is vertically opposite to this, because once again, these are both straight lines still. So when two straight lines cross, their vertically opposite angles are equal. So I'm just going to write this in. That's equal. And well, I also know that, so looking at maybe this straight line here, using the same logic as before, this is a supplement to our purple cross is a supplement to our orange dot. Hence, wouldn't this angle also be the same value as our orange dot, because they're angles on a straight line? They add up to 180 degrees. So let me draw that here. And wait a minute, these are vertically opposite. So these are equal too. Now, through this simple act of drawing these parallel lines and cutting a line through them, we make 8 different angles. Well, sorry, no, I shouldn't say different angles because a lot of them are equal, but we make a total of 8 angles. And from here, we can make some more observations based on which angles are equal. So I'm going to have to zoom this out quite a bit just so you see the full picture. Now, what other observations can we make? Well, okay, this angle and this angle are equal, the same as this angle and this angle. Well, if I were to draw, if in the same way I did with this one here, if I were to take a snapshot of one part of my big picture and close it into this, and this, we can see that when these angles make a type of Z almost, a Z shape, the angles within are equal. So that's a cool observation. Let me draw that. Let me take this snapshot, draw it down here. Sorry, I should add that I'm going to draw these little parallel lines here. And I'm going to go here. Oh, I'm going to do it in the same orientation as the image above. So here and here. Cool. That's parallel, that's parallel. These angles within here are equal. And lo and behold, we have a special name for these types of angles. These are called alternate angles. Oh, can't spell. Alternate angles. I'm going to put in brackets, from what we observed, are equal. That's pretty cool. Now, we also notice, well, cool, well, these ones are also equal. So no matter how wide we kind of make this Z shape, if it's present and we have the parallel lines, we can always identify alternate angles. Now, let's look at another maybe example that we see. Well, okay, this angle and say this angle, they skip sort of this one and go here, and they're equal too. So let's draw another little snapshot here. And I'm going to say, well, I'm going to locate here all the way down to here and this. This kind of F shape gives us these two angles here being equal. So drawing it one more time, I get this, and this here, along with my parallel lines. So, well, I know that from just what I've observed, that this is equal to this. I've color-coded these again, just so you can see that these are equal. Now, when we make this F shape, we get that the angles kind of within our F, so not the co-interior ones, but this angle with this outer angle are equal too. And these have a name as well. These are called corresponding angles. And these, we observe, are also equal. Now, when we're given a picture like this with two parallel lines, I could give you literally just one angle. So let's say X, for example, equals to, let's go 36. Using angles on a straight line, using vertically opposite angles, using our co-interior, alternate, and corresponding, we can use this one thing we know, one angle that we're given, to find 7 unknown angles. I think that's kind of cool. But have a go at working through this particular example when X equals 36, and with the current tools you have, I think you'll be able to comfortably answer this question. Now, these questions get trickier, but this is just an overview of how we build up this parallel lines cut by a transversal, which introduce us to 3 new angle relationships. Co-interior angles, which make this C shape, they add up to 180 degrees. Alternate angles, making this Z shape, being equal. Corresponding angles, making an F shape. Sorry, I keep saying F shape. Or Z shape or whatever, but they're kind of like letters. Maybe they are the shape of a letter, but anyway, whatever. This F letter, this type of shape of an F letter, produces corresponding angles, which are also equal. Now, I hope that helped, and have a go at questions like this in your textbooks, or you can just make them up for yourself as well. But now that you have all of your tools, you should be quite confident approaching these types of questions. See you next time.